within the game file, it's fairly empty right now. It doesn't do anything except launch a basic screen. The file that we did not build last class was our raindrop, or drop, because I got sick of typing out the whole word, so it's now called drop. This is why I'm encouraging you to use the starter files that have been provided today and work with that. Now, drop is written as all of these other additional files besides the game file. They are written as complete project files, so they all run as an individual item. So within this, if we look at it, we'll see that it has our standard setup and draw. It creates a new instance of our drop class. It tells drop that instance to update and display. If we look at drop, it's got the same things that we applied to the ball object prior. So going into the intersection file, which we rushed through at the very end, currently this now has our intersect function, takes the two ball objects and says, hey, are they intersecting? And then within our draw loop, we said if they intersect, highlight. Highlight just changes their fill color so that when this runs, we can see when they're overlapping, we get a little change in the fill color. So it now is a fairly straightforward file. It just has the balls bouncing off the side walls, not very exciting. The drops, to fit with the concept of things are falling and we're catching them, are set up so that they have a Y speed, and when they hit the bottom, right now they're being reset to the top. So in their update function, they update their position, and then they check to see, hey, did they go off screen? If so, move them back on to the top of the screen so then they can keep falling, because the check bottom function just returns true or false when we find out have they gone off screen. And it's padded a little bit so they can stay off screen for a little bit, so we don't quite realize it's the same drop looping. It just adds to the visual flair. That's why we are checking when their height is greater than, or when their Y position is greater than the height of the document plus the radius of the drop times 4. So if we run this, we'll just see that it just creates a drop that falls, and then it keeps falling, and it keeps falling, and it keeps falling, and it will just run forever. So there's no additional functionality built into this yet. That's what we get to add to it a little bit later today. So we have a falling drop. We have our catcher object. We have the logic of two objects intersecting each other. And we have a timer that we're going to want to be able to use, because if we use this timer, we will be able to then control the release of the drops so they don't all just fall at once. But we're going to add in the pieces one at a time as we build out the finished game, instead of just dumping it all in at the same time and go, whoa, it broke and crap, I don't know where to go to fix it. So the goal is to take pieces from each one of these and start integrating them into the game project. So we will use the timer, we will use our intersect function, we will use the drop class, and we will use the catcher class, and then we'll put it all in. All of that logic, all of that code will end up inside our game file that we will be working on. It makes sense when we're doing this to at least start out with the basic, or the most basic object that we had, and that will be the catcher. So what I need is, I just need most everything that is in the catcher, and I will be dumping that into my game file. So I will copy paste it one chunk at a time. So I'm going to go grab the class, then go over to my game, and I like to just put these extra lines of slashes in here, comments, so that when I look at the code, it's easy to figure out where the end of something is. So I can see over on the side here in Sublime, I can see, okay, there's my main game, and here is the start of my first class that I have. So there's my catcher class. And then we're going to need a catcher object. And I'll just call it catcher. Catcher is equal to a new catcher. And remembering that catcher does want a parameter passed to it, it's looking for the radius that I will be assigning to the catcher. And we're using radius again because when we have the radius of our objects, it makes our work a little bit easier when we're trying to find out if object 1 is intersecting object 2, because we are using a distance-based collision method for determining if our objects are intersecting. So that's where we compare the distance between the objects versus the sum of their radii. And I need to just stick a number in. Now, my game file, let me just get rid of this so I don't have to see that anymore. My game file adds a catcher once I put my semicolon at the end of the line. So I say a new catcher, but I do need to specify how big I want it to be, so I can just give it a radius if I want. Actually, that's too big. I don't want my catcher too big because it makes the game too easy. Though you could if you made everything fall fast, if you had a ton of objects, and that's part of the gameplay you get to figure out. So I'm making a new catcher. It's 32. If I run this and take a look at it, we'll see that nothing happens yet because my draw loop has not bothered to tell this catcher object that we've created to update or display. So because we never told it to display, we never had a chance to see it. So we always want to tell the object to update and display. Now, one thing that you will find over time is that you do start to standardize the language that you're using. I've standardized the two named functions that I attach to every visual object as update and display. Because of that, it will become so routine to reference those functions that you almost you treat them as built-in functions. The same way that if you call the random function and it gives you a random number and it's built in, update and display start to become normal for you. So it's important for us to, though, always remember update and display are functions that we have created. They are methods, to use the proper terminology. They are methods that are part of that class. So we can see in the catcher class, we have the method of update and the method of display. But these are things that we created. They are not built into the program. But if I run now, we will see that now I have a circle appearing on screen following my mouse. So the catcher object is working. The next object that we will add is we will add a single drop to prove it works, and then we will add an array of drops so we can have as many drops as we want falling on screen. Because if we can get 1 working, we can get 10 working or 100 working, but it doesn't make sense to try and write all of the code to get 100 objects working before we prove to ourselves that we can get 1 working. So it's important to do it in small pieces so then you can figure out where the breakdown is occurring when your file decides not to run properly or not to behave properly. So I'm going to go into my drop here and grab the drop class. I will copy that, go back to my game, and go down after my catcher class and paste in my drop. So I've now put in a drop. And I'm just going to call my drop D. D is equal to new drop. Now drop does not receive any parameters as part of it. I'm just going to collapse catcher so I don't have to scroll as far. So drop doesn't receive any parameters, so I don't have to pass anything to it. It's coming up with a fixed size. It randomly appears somewhere across left to right on the screen across the width. It has a random speed and or random, it has a Y position that puts it up above the screen. It has a random speed from 1 to 5, and then it's going to have color with some variance on the blue side, so it gives enough variations of blue to green. It has an update function. The update updates its Y position, checks to see if it hit the bottom, and if so, it wraps it back to the top. Display sets the fill, says don't use a stroke, and then draws the ellipse at that position. And here is the method of checking bottom, so that if it's exceeded the height, it gives me back true, otherwise it says false. So that's where the check bottom function, when it's being called here, when that method is asked, if it's true, then it resets its position. So that is the drop. So now I can say d.update d.display. So I have my catcher object, I have my drop object, and if I run this, you should see that it's now falling over here. Yeah, that catcher I think needs to shrink its size a little bit. If I run it again, we can see now it's in this, at a different speed, different location. Again, different speed, different location. So the catcher object is working, and our drop object is working. So our next plan of attack is either to work on dealing with the intersecting or dealing with dropping multiple objects. Adding in multiple drops is going to require us to use an array of objects so that we have our grouping of objects. And there's a couple practices that we will want to employ as part of that to make our code as good as we can do it. So we're no longer using a single drop here, but we're going to use an array of drops. So I say drop, and you specify an array with the square bracket. So we say this variable is an array, and I will call it drops. Now it is important when we have a class called drop and our array is called drops that we just keep track of when we're referencing the plural object, because it's really easy then to put the S on when you don't need it, or forget the S when you did need it. So it's just, you have to be vigilant. But as far as naming goes, I really think it is a better naming scheme, because this array is going to hold drop objects. And now this line here we will be able to recycle in a moment. So drops is equal to new, and it's going to be an array filled with drops. Now we need to specify how many drops are going to be in that. And instead of just hard coding a number in right there, it will actually make, because that number of how many objects are in our drops array, the length of our drops array, is a number that gets referenced multiple times in our code. So it actually makes sense to reference it as its own variable. I'll even just put a little return in between there. I'm going to get rid of that just so we don't have extra junk on screen. So we have our maximum number of drops. Now if I were to run this, I would get an error message because it's asking me to build an array with an integer which has not been assigned a value yet. So it is always important that if you're going to reference a variable in your code, you really should define it first if you want to prevent error messages. So at this point I can decide how many drops I want to start with. But by having this as a number here, I'm going to put it on its own line so it's easy to find. When we decide we want to go from 1 raindrop to 10 raindrops to 100 to 1,000, 10,000, well, at that point it's probably not going to run very well, but you could do 10,000 or 100,000. It's really easy. You change this number right here in the rest of your code because it's referencing this value, max drops. It works. I don't have to go in and change that number multiple times inside my code. It really is considered a good coding practice to define all of your number values as a variable, because then you can just go and change that number, because chances are if it's being used inside your code somewhere, it's being used more than once. There's a very good likelihood. And when your code grows to be 4, 5, 6, 800 lines long, 8,000 lines long, when you're looking for multiple instances of a number, it's not like searching for a name where you can, hey, look for this name. You're like, okay, look for a number. Well, numbers end up appearing all over, lots of times. So anytime you can define it with a variable, it's considered a better practice. So max drops is equal to 10. And now we just need to populate those drops into my array here. So we can use our for loop. And we'll start with it of, so it's 4, and then we define our starting value where we'll start at 0, remembering that arrays always start counting from 0. The first object in our array is at position 0, and that's what we'll be referencing. So that's why we start with 0. I is just this little temporary variable that we're using to iterate through this for loop. And then while I is less than max drop, so every time we run through this loop and do whatever is here, do something. So every time we go through and do something and then repeat the loop, I goes up by 1. So it starts at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And after we've gone through 10 times through the loop, then I becomes 10. And that means I would no longer be less than max drops when we've assigned a value of 10 to max drops. So it's a simple for loop that we will be then saying the object in the array at this position, position 0, is equal to a new drop. So this line of code, line 16, drops square bracket I equal to new drop, then takes and puts drops into the 10 positions of my array. And if using for loops and using the arrays is still something that it's a little bit foggy on your brain, it's okay. What I would say is use them because you're being told to use them. Don't fight it. And the more times you use them, the more your brain starts to go, oh, okay, gotcha, now I got it. A lot of things that you will find early on while you are doing coding, you don't fully grasp or understand, and that's okay. What you do is you take bits and pieces of code from a variety of sources, and bastardize them together and cross your fingers that it runs. Over time, your depth of understanding grows, and you start to actually comprehend what you're doing, and you can start to write more of it on your own versus having to start with someone else's code as your beginning departure point. So this now sticks a bunch of objects. I'm going to get rid of that comment because we don't really need it. Now I would encourage you, while you are working on your project, liberally fill the document with comments, please, because that will help you to remember what each line of code is doing. Put comments in. So I now have my array of drops. I've filled my array with a bunch of drops. And now we get to just cycle through that array and watch the drops fall. And to do that, we use the same for loop that we had here. Same drops I, but then we will be telling the drops to update and display. So I use my for loop. So now that I have my for loop, I'm not running a single drop anymore. So I'll move these lines up. Get rid of that extra one. But I can't tell D to display because there is no D anymore. For that matter, my drops don't even have individual names. I don't have drop 1. I don't have drop 2. I just have an unnamed drop that exists in each position of my array. And it's this concept of not having named objects, but just having objects in the array. So it's like if all of you here in class just had a number, and I'd say student 1 and student 2, student 3, and just base it on the computer you're sitting at, I can identify who you are. I don't have your name or anything else. I can just say who's sitting at student computer number 10 and go, oh, that person is the one I want to deal with right now. That's what the array really is I just have objects that are sitting at different positions within that array. But they don't have names. So I don't know what their names are because they don't even get them. And that's where we use, and don't forget the S. When I was writing up the code sample, I forgot the S when I was trying to do this, and it said, I don't know what a drop thingy is that you're referring to there. And I'm like, what? And it's really easy to forget. There. So we say the drop sitting at position 0, then the drop sitting at position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will now iterate through all of my drops. So if I run this, we should see the catcher still move. And instead of 1 drop, I will have 10 drops, and then they should all fall. And there they go. There's no interaction yet. And they fall perpetually because when they get to the bottom, they loop back to the top of the screen. The nice part is if I just say I want 100 drops, I just add a 0 to my maximum number of drops. The rest of my code stays untouched. And we run it and see now 100 drops falling. And that actually indicates, now there's some cool effects. The slow ones versus the ones up front, you get some really cool visuals where it almost starts to look like space. But if we run this again, you will notice that
where are we getting the different colors from?
in the drop itself that I provided today, it has a fill color where it's a variation on blue. So in the drop class, do you see in the drop class? Do you see where in the constructor for the drop class it says C equals color? That is where the color is. So if you want red drops, change that to be a red color. I just chose a variation in blue. All right. So before we go on, we need to make sure that whose code is broken? Do we have any broken codes? Yours broken?
No, I actually have brain drops, not circles.
Oh.
Yeah.
Oh, you added the pointy drops as per the book because it's cool? We might get there. Do you like it better that way?
Yeah.
Yeah, look at raindrops.
It actually is like.
And it's neat that they used a for loop to pull that off.
How does it work? I don't.
It's just a series of shrinking circles.
Oh.
So, how many people actually tried to build the raindrop class as it was indicated in the book? Was that kind of a cool effect where it created the tapered drop? Especially considering all it is a series of circles overlapping to effectively give you tapered drop. It's really kind of cool that way. So they didn't use any complex shape objects or anything. So in the book, when it draws the raindrop, what it did is it drew a circle, and then it shrunk the radius, and shrunk the radius, and shrunk the radius, and shrunk the radius, and shrunk the radius. I think it does 10. Is yours 10 up or?
And just I is
I
less
is-
than R.
Yeah.
Oh, so it's based on the
R.
radius.
Yeah.
So it's based on the radius of the raindrop. But if I take these circles and instead of spacing them out, like that, and erase the overlap because they don't have a stroke on them, it creates a raindrop. It's cheap, easy. Just use the little for loop. But the thing is we can easily add that to what we're doing right now by just going into the drop class and modifying our display function. So we don't have to change any other logic in the whole thing. And this is part of the power of building things in this manner by separating out the appearance from the behavior of an object. We're able to then construct these kinds of things very easily and readily. So maybe, time permitting, we'll add that in later on this morning. To catch the objects, we're going to need to bring back our intersect function. So looking back at the intersect project or sketch, it moved the different, this time it was using balls and not the drops, but as they intersect each other, so when object 1 intersects object 2, they change color. So we get to see that effect occurring. But it's taking place through the use of the intersect function. So what we need to do is to cycle through that intersect function. So I'm going to go into my intersect sketch, copy this function just from Boolean intersect all the way through to its closing curly. So I'll copy that, then go back to my game. And after my draw function, I will then add that because this is not going to be in a class. It was written to be independent of classes. Now, currently, the intersect function is looking for 2 ball objects. But we are not using ball objects in our catcher game. We are using drops, the drop object, and we are using the catcher object. So we're going to have to modify this a little bit, but that's pretty easy to do. My intersect function here, now before I update the drops, I want to find out when they are intersecting the catcher object. So the intersect function is currently taking in 2 objects, ball A and ball B, but we want to take in catcher and a drop object. So we want to know when a catcher object is intersecting the drop object. The good part about that is the drop object has an X and Y. The drop object, or the catcher object has an X and Y. The drop object has an X and Y. The catcher object has a radius. The drop object has a radius. Now, if it would make you happier to not use A and B, but to use C and D, catcher and drop, because then the names line up. Feel free to change your code. I'm not going to, because this will work like this, so I don't need to change anything else. So what we're going to do is we're going to then, when we loop through the drops, before we update or display them, we are going to determine if they have intersected the catcher object. So in the draw function, before we update and display the drops, we want to know, have they intersected? If intersect, and then we have to say what, catcher and, so if intersect returns true with catcher and drops, and I'm using verbose, so if intersection is true, because when we use the intersect function, it returns the Boolean value of true or false. So I can write out the true, but if we just say if intersect, then that's the same as saying if intersect is true. So that double equal sign, and notice that is a double equal sign because we're comparing, we're not assigning. Assigning values, single equal sign; comparing values, double equal sign. So we're comparing the value of the intersect function with these two objects. We're comparing that to true, and if that is the case, then we need to do something. The something we want to do is we want to tell our objects to stop moving. And we can accomplish this in a couple of different ways or different methods. So my drop, when it intersects, to prove it's working, first I am going to, before we add a method, before I add the method, I'm going to just, because technically I should know it has a speed y, but we're assuming it does. And I do need my s on my drops. And we will set my speed y equal to 0. So if I intersect, stop it. So when intersect happens, we take, oh, it's y speed. Whoops, that would have failed. Y speed. So we set the y speed of the drop to 0. Run this. When I intersect, we can see as I catch them, their y speed is now 0 and they're parked. It's not great form to be hard coding a property of the object here. It's much better to be referencing it through a function. So we proved this works, but now we're going to go into the drop class and update that object so that it has a stop moving function. So the same way it has its update, it has display, it has check bottom. Now it's going to have an additional method that we'll work with here. Just going to get some extra space to go with. And this method doesn't return a value. And we could refer to it as stop moving for the pacifists in the room here. We'll call it stop moving. And then it's y speed equals 0. So this method we can then reference or call. So instead of saying y speed equals 0 here, I can just call stop moving. The other advantage to this is as we add additional functionality into our game, we're going to find just setting the y speed equal to 0 is probably not going to be enough, and we're going to need some other things to happen. So it makes sense to have this method that will become more than just simply assigning the speed. Because if it really was just changing the speed and that's all we wanted to do, then that would, we probably wouldn't have to go to this effort. But now that we're doing that, we can add in more into it. So now if I run this again with, say, 100 drops, it becomes that much more apparent when we start catching them all. How it's working. I can see that we've now captured or stopped those drops. Some of you may decide that you don't want to see the drops anymore after you catch them. So one possibility that you could look at is you could then modify it so that instead of not seeing them, they disappear. So they could disappear from the screen. So that not only do they stop, but then they disappear. And we could do that in a variety of places. To make the drops disappear, one of the options that we can do is we can change their Y position. So once they're stopped, you can set, say, Y, or for that matter even X, equal to a very large negative number. So if we say minus 1,000, and now if I run this, we will see that the drops disappear as I catch them. So it gives the illusion that I actually am catching all of the different drops. Part of the challenge to you is to figure out, okay, taking that, how can you make this richer and more interesting? You could even think in terms of, well, perhaps say I have 100 drops I'm trying to catch and they're all blue. If my catcher starts out white, every time I catch a drop, I could make it 1% closer to being blue. So it indicates by its color change that it's catching and being transformed by these objects. Maybe it grows. Maybe the radius of the catcher changes for every drop you catch, indicating it's like a sponge and it's absorbing these. So you can now take very easy things, modify the radius, modify color based on how many drops we're catching, and we can now create a visual feedback that enriches the gameplay. But those pieces I'm going to be pushing on to you to figure out how to do that and where to do that to create your own rich game. Integrating the timer object means I need the timer class. So we can go into the timer file that was provided and grab the timer class. Well, notice that the timer, when it's constructed, requires us to say how much time we want to be in the timer class. And then the timer has two methods of start and is finished. So I'm in the timer file, I'm copying just the class, and make sure you get its closing curly at the end. I'm going to copy my timer class, go back to my game, go to the bottom, and I will paste in my timer class. I will not have to make any modifications to this class to make it work. So theoretically, I can run my project again and it will run. So I've put code in at the bottom, nothing broke. That's a good sign. Run your project frequently so that you're not left watching it suddenly start breaking. So now I need to add in an instance of my timer. So I make a timer variable. So I referenced the class name, capital T timer. My variable instance will be lowercase t timer. And inside my setup function, I can now give this a value. timer is equal to new timer. And now timer is wanting me to tell it how frequently I want it to refresh, or how long I want the timer to run. And the answer to that is I'm going to go with 1 second. The timer class deals in milliseconds, thousandths of a second. So when I say 1,000 milliseconds, that's 1 second. So timer is new timer. So that now creates a new timer. Now, as I'm working with this, I need to then work a little bit differently, because I need to then figure out how many drops are currently active in my project. If I change max drops to 1 so I'm in my dry loop here. Don't do this. I'm doing coding for explanation purposes only. If I change it to 1, we see just 1 raindrop is falling. So if I change that to 2, we'll see 2 raindrops fall, but, and this is the big but, I still have 100 raindrops at my disposal. I'm just choosing to only see 2 raindrops fall. So I am going to propose that we make another variable and call this active drops. These are the drops that are currently active or animating. And active drops will start at 0. So I have an integer of active drops. So my maximum number of drops in this instance is 100. I'm going to start with 0 drops active. And my loop that cycles through all of my drops is going to only go up to however many drops are active. So if I set active drops at 0 and run this, we will see exactly 0 drops active. If I change active drops and say it's 5, then when I run this, I should see 5 raindrops immediately start falling. So what we can do with this is start it at 0 and then use our timer to keep cranking active drops up. So in this case, every second, every 1,000 milliseconds, I want to increase active drops. I want to make that number get bigger. So we can do that by simply saying if timer is finished. Now, that particular method of timer is built in the timer class. Looking in the timer class, we can see it has, and I'll go back up to the code in a moment, but the timer class has a method of is finished, and it returns a true or a false value. And the timer class also has a start method, which we'll need to take advantage of as well. So if the timer is finished, at that point, what we need to do is we need to increase active drops. So we can just do active drops plus plus, or we could say active drops plus equals 1, or active drops is equal to active drops plus 1. All of those are equivalent coding statements. Now I'm going to reduce my number of drops down to 10, and there will be a reason for this that will understand, because I want my code to fail. What I've done right now will actually break. So we do need to start the timer. At the end of setup here, I can say timer.start. So we tell the timer to start. And then every time the timer is done, we increase active drops, and now I can say timer.start again. So we can reference, and ask the timer to start itself over. Okay. So that now gets the timer starting over. But I have a fatal flaw in my code right now. So because my project failed, I need to prevent active drops from ever getting too big. And that's the same way we do anything else on the computer. If active drops is less than max drops, that's when we want to do those two things. So we only want to increase active drops when it's less than our maximum number of drops. And now I can run this with no error messages. And this also now creates the situation where I only get one drop falling, then two, then three. So it's a nicer thing. Now, if I increase my number of drops, and if I decrease my time so that they start falling fast, well, we'll leave it slow first and watch, and then I'll increase the time. Then we'll see that it gives a nice, and now I'll just keep on going until all 100 drops are falling. But if I decrease the time, we'll see that we're not getting the bucket drop. We're still getting a more natural 1, then 2, then 3, then 4 type of animation with this. And then I can work on catching them all and ending the game. As we go into looking at it on wanting to display text on screen, which we have not covered yet, an easy way to figure out how to do that is to go into the reference itself for processing. And if I look in the reference, it's under typography and it's text. Otherwise, I can go A to Z. And if you think about it from the concept of I want to show text on screen, you look A to Z and you go, okay, T, text, there it is. Look it up. Now, the text function in processing, you just write out text, put parentheses, then you provide the string that you want to display, and you provide the location in which you want to display it. If you want your text to be a color, you need to provide a fill value before you issue this statement, just like everything else. Your circles, your rectangles, your lines, your points, shapes. If you want them to be a specific color, you provide that fill color first. So again, it's text, the string you're trying to work with, and the X and Y location. You can also create a text box if you need that. This is a good example that it uses a string variable, and we're actually going to be doing that, and we call it S for string. Specify our fill color, and then we have our statement of text, the string variable, the X and Y, and we're not going to worry about wrapping it into a box, so we won't need those remaining two values. So that's the gist of it, right from the reference for processing itself. So knowing that, in my draw loop, I'm going to put some text on screen first to prove that I can. Then we're going to kind of clean up how we do it, and then we're going to make a score variable so we can start keeping track of our score so that we get a nicer sense of user feedback. Some of you are competitive and like that type of my score is better than your score kind of thing, and you can go nuts with that. But to get it to show up on screen, in my draw loop, I am going to say text, and now I'm going to pass in a value. First, I'm going to start out and just put some text on screen to prove that this works. Then we're going to use the variable and use the score and do it properly. And I can say, hello, are you smiling yet? So I've constructed my string, and then I will pass in a location. X is first, and then Y. Now when I do this, if we think about what's currently on screen, I draw my catcher, then I draw the drops, which means my fill color is going to be left at whatever the last drop was. So theoretically, I should see some blue text show up on screen. It started gray, then it went to blue, because before the first drop showed up, the fill color was gray because that's the color of the catcher. So if I want my text to be colored, I can specify a value. I'm choosing red as my value, just to make it really stand out and so that I know that is indeed what is happening. You can see now it stays red even though the drops are falling. So we've proven that we can get text to show up on screen. Now that we have proof, we can get text to show up on screen. We have a string and a location and a fill color. It's time to control that a little bit better. So what I want to do is I want to have a score value. And then I want that score value to change every time I catch one of the drops. So to do that, we're going to need a variable. I'm working with my score as an integer because I don't see a fractional score fitting in as my value. So I can say int score. Now I also like storing what I'm writing as text in a string variable. So I like to have string s, like the example in the help document. Now notice string is capitalized as a value. String is a class type object, much like the classes we've made. Therefore, it gets a capital first letter. So I have string s and then an integer for score. So now I can give those value. Score equals 0. Just be warned, it's very common when typing the word score to do SCROE. It's a very common typo, and you won't really notice it till your code breaks. So when you're typing in the word score, I don't know why, because those are separate hands, the O and the R, but they do commonly flip-flop. In my own code and students' code, I've seen that typo occur a lot. So if your score isn't working, check your variable name. So we can set the score equal to 0. Now when we catch a drop, it makes sense to increase the score. So if I intersect Now we can take whatever score we had at 0, and if we decide that each object is worth 1, we can just do plus equals 1. Oh, wrong key. If we wanted to have her score be hundreds, so everything we catch is worth 100, then we could go plus equals 100. So if you like bigger numbers because it's score inflation, it makes you, as the player, feel better because it's giving you a huge score. It's kind of like on a pinball machine where you get scores in the like 300 million points and like, wow, I'm awesome. It's like, well, not really. It just scores really high. You could be awesome, but not because of that score. So this increases our score. Now, I can set the fill color for my score. Then I can say S, my string, is equal to score. And we can add variables, even if they're numbers, to this existing string. So we can say S, our string, is equal to the word score, in quotation marks, plus, and score. When we're working with strings, we can create composite strings by adding those strings together. It effectively just adds whatever within the quotation marks together. We can also add in variables, be they numbers, floats, or integers, and combine that with it, and it will represent it to us. And then our text statement just says text S is equal to, or it said we fill it with that string, and then we put in the X and Y location. So you don't technically need the extra string variable. But for readability of code, I believe it makes it easier to store that string that we're going to then use the text function on in a variable object. And if I run it now, score starts at 0. Every time I catch one of the drops, my score goes up by 1. If we look on screen, we can see score starts at 0. I caught 1. I'm now up to 1, 2, 3. Oh, and my game only has 3, so it's not, there's no checking to see if I have won the game yet or not. It's just running. So I caught the 3, and it's not doing any other activities. We would need to then add in a conditional statement and say if score is equal to max drops, then we could change the message to U1. So we could change S to U1, or we could go to a new screen. There's a lot of options that are available to us at that point. To facilitate a little cleaner modification of code that we're going to need, I am going to then change the order slightly from how it was written. So I have my score. Then I have my updating the visual information on screen. The 5 lines of code that we will be looking at are all inside the draw function, because currently the draw function is getting ugly. It's cleaning up the background, it's moving objects, it's spewing out the timer, it's updating the score, it's putting text on screen, it's doing all kinds of things. That's way too much. Instead, it would be better if it now just references activities or functions, because that really will be necessary to allow us to take this project to that next level of building the gameplay states of start, play, win, lose, and then being able to go back to the beginning to start and having that perpetual loop. So all of this is going to need to be moved into a set of functions. Now right now some of it will be, you may feel that, well, that's kind of, there's not a lot in that function. Why am I going through that much hassle? But what you will find is when we move to using the states, it's mandatory that you've done that. So your homework is to try to do this, and then we will pick up from this next week and build those different states into your game. So the first will be clean background. And again, don't start typing right now. Just watch. And I want you to maintain the naming that I'm using here, because then I'm going to continue with this file forward. And if you rename all your functions differently, then you will have to keep going back and forth of, well, his says this, mine says this, and why is it not working? Because you'll use both names in yours. So stick with the names I provide for this, just because that way our documents will be interchangeable. So we clean the background, we spawn the enemies. We're going to move our objects, update the UI, and then check when. So these 5 functions you're going to be working on. Check when. I'm going to leave it up to you to try and figure out how you think it would be a good strategy to implement that. And we will take a look at your solutions next week on check when to figure out, have you come up with a good idea for that. The other functions really are just going to be, you write the function and then you move a line or 2 or 3 from this draw loop into that function. So for instance, clean background, you write that clean background function and then you really only have to move 1 line of code into it. Background. Now you could decide you don't want the background to be just wiped clean. You want to have that kind of ghosted trails background. So you modify your clean background function. So instead of just saying background 255, it sets a fill color and draws a rectangle at a certain degree of transparency, so as it cycles through you get that kind of ghosting trail effect, because you want that as part of your project. Cool, do it. So you can now customize it, and by having it in its own function, it becomes really easy to now encapsulate that code so that when you change that, it doesn't wreck something else going on in your project. So you need to modify it so when you come back next week, your draw function just has these 5 functions referenced, and then you've taken this code here and put it into the appropriate place, and you've done your best guess attempt at figuring out how to write a check when function and what needs to happen with that. That's the homework. Have fun, good luck, and try to smile.